Hello everyone, welcome to CodeChef YouTube channel. Myself Pradyumna, and today we'll be discussing the problem reversal sorting. Its problem code is REVSORT and it appeared in the June long 2 2022. It's easy level problem, so let's read the problem statement and understand it. So the problem states as chef is deriving weird ways to sort his array. Currently he is trying to sort his arrays in increasing order by reversing some of his sub-arrays. To make it more challenging for himself, chef decides that he can reverse only those sub-arrays that have sum of its element at most x. Soon he notices that it might not be always possible to sort the array with this condition. Can you help the chef by telling him if the given array can be sorted by reversing sub-arrays with sum at most x? More formally, for a given array A and an integer x, check whether the array can be sorted in increasing order by reversing sum, possibly none of the subarrays, such that the sum of all elements of the subarray is at most x. So what's the problem is saying? We'll be given an array of n elements, the array will be like a1, a2, a3 up to n, and will be given an integer x. And there will be an operation that we can reverse a subarray if the sum of elements in that subarray is at most x. For example, if the array is a1, a2, a3, a4, a5, a6, a7, and we choose the subarray a3, a4, a5, a6, this subarray can be reversed if a3 plus a4 plus a5 plus a6 is less than equals to x. So if that is satisfied, we can reverse this subarray, and after the operation the array will look like a1, a2, then a6, a5, a4, a3, a7. This subarray part is reversed. So what we have to do is, we can do this operation any finite number of times. So this can be done on any subarray that satisfies this condition and any finite number of times. So we have to print whether by doing this operation any finite number of times we can sort the complete array in increasing order or not. Like, can we sort the this given initial array in increasing order or not by doing this operation any number of times on the subarrays which satisfies this condition. So that we have to find out. So if it is possible, then we have to print yes, and if it is not possible, then we have to print no. The input format for the question is, the first line will contain t, number of test cases, then the test cases follow. The first line of each test case contains two space separated integers n and x, denoting the length of the array and the maximum sum of subarrays that you can reverse. The second line contains n space separated integers a1, a2 up to an, representing the initial array. The output format for the question is, for each test case, output yes if chef can sort the array using a finite number of operations, else output no. You may print each character of the string in uppercase, lowercase. For example, the string yes will be treated as identical. Constraints. T is between 1 and 5 into 10 power 4, n is between 1 and 10 power 5, ai is between 1 and 2 into 10 power 9, and x is between 1 and 2 into 10 power 9, and sum of n over all test cases does not exceed 3 into 10 power 5. Let's look at the sample test cases. So herein the number of test cases t is equals to 3. Coming to the first test case, n equals to 4 and x equals to 1, and the array is 1, 2, 3, 4. As you can see, it is already sorted, so we don't need to perform any operation because in the question it is said that possibly 0 operations also. So herein no operation is needed, the array is already sorted, so the sample output is yes in this case. Coming to the second test case, n equals to 4 and x equals to 1, the array is 2, 1, 3, 4. So to get the array sorted, we need to bring this 2 to this position and 1 to this position. That means if we could reverse this subarray, then we'll get our array in sorted form. But you can see that x equals to 1, so we cannot reverse this array because the sum will be 1 plus 2 equals to 3, that is exceeding this x. So we can't reverse this subarray. So without reversing this subarray, there is no possible way to get the whole array in increasing order. So it is not possible to sort the array. So the sample output for the second test case is no. Coming to the third test case, n equals to 5 and x equals to 7, and the array is 3, 2, 2, 3, 3. So if we choose this starting subarray having 3, 2, 2, that is 3 elements from the starting, then you can see that its sum is equals to 7, that is less than equals to 7, the value of x. So it can be reversed. So by reversing this subarray, we get 2, 2, 3, then after that the following 3, 3. So now you can see that this array is in increasing order, that is 2, 2, then 3, 3s. So it is in sorted form using this operation once. So sample output for the third test case is yes. So let's talk about the approach, how I'll solve this problem. So let this be the array A1, A2, A3, A4 like that. So the core idea will be till a position I in the array, if mx plus any element up to I is less than equals to x, then till I the array can be sorted. So here mx denotes the maximum element till I. So why I am saying that, let's see with an example. So herein I have taken an example, that is the initial array be 2, 1, 5, 4, 3, 6 like that. So I am considering my I up to this 3. So I am marking here, and let's first sort this I. If this is possible, then other i's, like other positions, this I is like for a general case. So that can be the I can be made at any position. So if this is proved, then other positions can also be sorted, and the whole array can be sorted like that. So herein up to I, the maximum element till I will be 5. So mx will be 5. So this is, let's discuss one very important thing, that is if mx plus any element up to I is less than equals to x, then sum of any two element within I, like this up to I, if you choose any two element, then their sum also will be less than equals to x. Why? Because mx plus any element, this is also constituting two elements, as mx denotes the maximum element till I, as one maximum element is already present in this equation. Any element if you are choosing, then that can be the second maximum also. So if that is less than equals to x, that means all other elements, if put in place of this any element up to I, will also be less than equals to x, because all other elements are obviously less than the mx, less than equals to. Then the sum of any two elements within I, that means if you choose greatest two numbers within this I, that would be also less than equals to x, because that we have got from here only. So we can say that sum of any two elements within I will be less than equals to x if this condition is met. So now it becomes very simple. We can choose this subarray, because so this two, if this two sum, that is 1 plus 2, be less than equals to x, then it is reversed. So 1, 2, then this 5, 4 will be reversed, then 5, 3, then this 4, 3, then we got our array to be sorted. So if we check this, like if 5 plus 2, 5 plus 1, 5 plus 4 and 5 plus 3, if everything is less than equals to x, for this case, then we can say that this initial I part can be sorted in increasing order. So what we'll do is we'll start traversing the array from the start, and at every I we'll check this condition. If mx plus mx is greater than x and mx plus a is greater than x, if this condition is met, then we'll mark our flag variable as 0. So this flag variable means if fl is equals to 1, then it is possible to sort the array in increasing order, and if fl equals to 0, then it is not possible to sort. So here what I am doing, if this mx till now plus ai is exceeding this x, then it is not possible. That we have like found out from here only. So why I am checking this condition that mx is greater than x? I am checking this because if x is greater than mx, that means till I x becomes the greatest element. So in that case, this condition need not to be checked, because the greatest element till I is already present at the last position I. So if that is not the case, if the mx till I is present before I, in that case, if mx plus ai is greater than x, then we are marking the flag variable as 0. If x is greater than mx, then we don't need to check this, because the greatest element till I is already present at I only. So this is the additional condition that I have added. So in this case, like 2 1 4 3 5, so you can see 5 is already present at the last position among the 5 elements. So we only need to check for 1 2 3 4 whether they can be like swapped or not. So this 5 is already present. So in I am checking this condition, so as if I equals to 5, then it will ignore this index, and fl will be set 1 only. This will not enter to checking this condition itself. This will ignore and continue for the next part of the loop, because it is already set in its position. So I am doing this, and after it is checked. So if this is true, fl will mark 0. That means the array cannot be sorted. And if it's not met, that means yes, we can reverse the array and make it sorted. So after every till I equals to n, we'll iterate this, and in position we'll calculate the mx also, like update it mx equal to max of mx comma ai, and finally we'll check our flag variable. If it is 1, then we can sort the array, and if it is 0, then we cannot sort the array. If you are still unable to understand the problem or not able to get the correct answer for your code, then don't worry. You can ask your doubts to doubt solver. For that, go to the practice section, and after that you can search for your problem. Let's say the problem name is DNA storage. After that, click on your problem, then go to the problem statement. So there is a section called ask a doubt. After that, you can start asking your doubts to the doubt solver, and doubt solvers will solve your doubts instantly. So this is a C++ code that got accepted. So first of all, I have taken the input for number of test cases, and in each test case I have taken the input for n and x, and after that I have declared one variable mx to store the maximum element till I, and one flag variable initially set to 1, and after that I have started iterating from 0 till n, and in each iteration I have taken the input for ai in the variable num, and I have checked my condition, that is if mx is greater than num and mx plus num is greater than x, then I have set my flag variable to 0, and after that I have updated my mx to the maximum of mx and num, and after all the iterations I have checked if if my flag variable is 1, then I have printed out yes, because in that case the sorting the array in increasing order is possible. Otherwise no, because it is not possible in case of fl equals to 0. So this is the C++ code. So this is the Python solution that got accepted. So first of all I have taken the input for number of test cases, and I will loop for that many times, and in each test case I have taken the input for n, x and the array a, and after that I have declared one variable mx to store the maximum element till I, and one flag variable initially set to 1. And after that I have iterated from 0 till n, and in each iteration I have checked if mx is greater than a of I and mx plus a of I is greater than x as per our condition that we have discussed. And this is true, then I have set my flag variable to 0, because in that case sorting the array is not possible. And after that I have updated my mx to the max of mx and ai, and after that, after all the iterations is over, I've checked if fl is 0, then sorting the array is not possible, so printed no. And else if fl equals to 1, in that case sorting the array in increasing order is possible, that's why I printed yes. So this was the Python code. So that's it, and thank you.